Welcome back to a cool and sunny day in Thailand, and it's New Year's Day 2019. First time I've said that. As a wise man once said, nothing changes on New Year's Day. So I'm back at this board and the firmware. Today I'm going to build the menu system that allows the user to interact with the board, specifically to display volts and amps, set and display volts and amps calibration factors, and set and display CANBus ID, because I'm going to allow the user to select their own CANBus ID because they may have a fairly complicated CANBus with many devices, and I want to make sure I'm not in their way by creating a conflicting ID. This will then roll over into the need for persistent storage. I'm going to need to store and retrieve the calibration factors and the CANBus ID between reboots of the device, which means I'm going to have to use some of the, I don't know if they call it EEPROM, or there's another term they use for persistent storage inside the microcontroller. And that'll be it for today. So let me get working on that. Okay, I managed to build myself a little menu system. We'll let it run here and see it come out. And so the board identifies itself with version numbers, and it picks up the date and the time of the last compile. My information with email and the documentation website. I'm going to update that with the GNU public license information, but I don't want to make it too verbose in here. I'll probably put the full GNU license in the bit.ly link. But we've got 5 possible commands. Setting the maximum amps reading of the ACS 770 chip, the voltage offset calibration factor, the voltage full scale calibration factor, and similarly for amps offset and amps calibration, or full scale. Oh, I have to fix that. And then the CANBus ID. And these are all just reading fake values right now. So what I need to do is build a system where I can enter the command and then update the value inside the code. Welcome to a drizzly day in Thailand, and we have survived the tropical storm that blew through southern Thailand. I'm about 300 kilometers north of there, so we just got a little bit of drizzle, which will continue through today and tomorrow. And here's a picture of the waves that my buddy took down on the beach, and he's getting his surfboard out, so enjoy that. And I'm connected to the Atmel ICE debugger, and I ran into a problem. Normally with the ICE debugger, and this is going to be a little ugly as I try and hold everything in place, with the ICE debugger, inside the Atmel Studio where you write your code, you set up your device programmer, which actually pushes the firmware into the microcontroller, but it's also your debugging tool. So you can't do anything without this working. So what I've done is we're using the Atmel ICE debugger, and it picked up the serial number, which is fine. This is the chip on board. We're using the single wire debug technique, and I click apply, and it has found the Atmel ICE. If I click it again, you'll see that little green light go on. It's communicating over USB to the Atmel ICE box. Everything's good. But now when I come back here and try and probe the chip to make sure everything's good, I say read, and we get this error message. No device detected, error 4109. And that's a big problem. Searching on the Atmel forums, it quickly became apparent that the microcontroller, if you write your software in a certain way and you put it into sleep mode, it will never wake up. And the debugger cannot get a hook into the processor to let it start debugging, upload new firmware, fix bugs. At that point, the chip is potentially dead. Now, some of the family of chips, the ones with the package with more pins, they actually have an erase pin, which you can manually trigger an erase of all of the code in the chip and basically start as if it was from the factory. The debugger doesn't have the ability to do that for you, and unfortunately my chip does not have the erase pin. So I thought, oh, all right, I need to unsolder this chip and put a new one in. I am not playing with the sleep facility at all, but there's this, I've been working on getting the user menu set up where I display the different configuration commands to the user and then try and read back the response. I could have screwed something up with that and caused itself to go into an infinite loop that it can't break out of. So I thought, all right, let me try the first version of the board that I did, which is here. It's still been on my shelf, and I had to hook up 12 volts to it. And guess what? I get exactly the same message, even without loading any firmware into this board. That tells me that the board isn't the problem. It's something from the board upstream. So what could that be? The obvious issue could be this cable. It's a very, very delicate cable with a 10-pin header, 1.27 millimeter spacing on the pins into the ice. Now the ice appears functional to the point where the Atmel Studio can talk to it. And the funny thing is, if I come back here, if I come back here and I click that apply again, and then I click read, you can see here that the ice has read the voltage off the board at 4.7 volts. So that tells me that the pin that goes from the cable to my board that's reading approximately 5 volts is working. But the pins that are controlling the data flow, there's a data pin and a clock signal, and then the data goes 01010001. I'm thinking there's a problem with that cable. So I tried swapping ends. That didn't help. And I thought, all right, I got to buy a new cable. So Atmel actually sells a replacement cable part, but of course there are none in Asia. I would have to pay $20 to ship a $9 cable from one of the distributors in North America. But then I realized, hey, this is a pretty not counting this because this is for debugging another type of board, but from here to here is a bog standard 10 wire with a header on each end. So I went ahead and I bought one from China because I couldn't find one in Thailand. And so I'm going to be doing that. Now, one thing I found in reading somebody's blog, if you look carefully, and this is going to be very hard to visualize, so forgive me. Let me get some light here. The direction of the header pin, and I'm going to disconnect this so you can see better. Now look, this header is pointing down, and we come across and we pull this flat. This header is pointing up. One end is up, one end is down. This is a non-standard connector facility. And there were a lot of choice words on that guy's blog about the stupidity of the engineer who decided to make the pin out of the cable this way. So that means when I get the cable, I'm going to have to pry off one end and then try and reconnect it on the other end. But then I thought, hey, if I just have a bad connection here or here, I can just pop the cable off and reinstall it closer in on a hopefully good part of the actual ribbon cable. So that's what I'm going to try now. Because otherwise I'm kind of dead in the water. I can't make any progress on the board if my tools don't work. And this is the most likely culprit. So let's see what happens. Well, before I did major surgery on the cable, I realized that I have these little connectors that I solder onto the board. What if I plug these into the ends of the cable and then buzz the cable with my ohm meter to see what happens? And the cable's okay. Sad to say, each pin is connected to only its corresponding pin on the other side. There are no breaks, there are no shorts. So I'm starting to think it's either the ICE board itself, which looks fine. There is no physical damage, no cracks, no brown smears, no magic smoke, or something in the software is not talking, or my microprocessors are truly stuffed. So I'm going to try a little bit more, and then I'm going to replace the processor. Okay, so if the cable is good, I'm running out of possibilities. So the easiest thing for me to try to do is uninstall and reinstall all the Atmel software. Atmel Studio 7 will pull in all of the required drivers, and I'm not going to install any updates. I'm just going to try it raw and see what happens, and then apply updates from there. Okay, after a clean install, I'm back here. It's detecting the Atmel ICE device, but I'm still getting exactly the same message. It cannot talk to my board. So next step is to unsolder the microcontroller and put in a new version one and see what happens without any code running on it whatsoever. We'll see if we can just talk to it. Okay, the board has a new microcontroller, if you can see in the light. And boy, was this a lot easier to deal with after I watched about 100 of Louis Rossmann's videos on soldering and unsoldering, especially these small flat chips with the air desoldering station. Now we're plugged in, we're powered up, and let's see what happens. Sorry for the focus. Okay, and click. We're talking to the Atmel ICE on our chip, ATSAM C21E18A, and read. No. Exactly the same error. So it was not the microcontroller that was the problem. That means the only thing left is the board inside here. But I have one more thing to try, and that is an Arduino Due. And if you look very carefully, right up here, there's debugging pin set. And this is ATSAM 3X8E AU. AU is probably just a revision number. But if we can get the Atmel ICE talking to this board with this chip configuration, then there's something wrong on the board, and I'll build up a whole new board. But let's give this a try. Okay, the ICE is now connected up to the Due through the 10-pin debug interface. 5 volts power here. I configured the ATSAM 3X8E. Let's see what happens. So apply. Good. Read. Oh, look. No device. Damn. So let's take a quick look at the board. I've looked at this from every angle. I cannot find a single thing that looks bad. The only issue could be coming in here. This is the connector where we come in through some of these little LEDs that light up. And then there's a series of resistors and voltage level converters and diodes that prepare the signal to be read. If you look, I don't know if you can see, but 3 of those resistors have numbers written on them. That one doesn't. Now, it doesn't look damaged It's still firmly soldered to the board. It just looks curious to me. I've looked for the schematic for this board on the web. I cannot find it. I've looked at other images of this board, and none of them are clear enough to read off the resistor value. This resistor is 330 ohms. The unlabeled one is 680 ohms, which is good, means it's not blown, would be infinity. This is 1.5K and another 330, so I have no way to validate that those values are correct, but I don't see any other damage to the board in any way, so I think my only option is to buy a new board. And it's going to cost me a pretty penny and take a long time, but this is my only option left. Okay, that's it. I give up. I went on AliExpress and I bought the bare board, which has the code PCBA in it. It was $68 plus $4.21 shipping from China. It'll get here in 12 to 22 days, of course. I could have ordered it from America. It'd be here in 4 days, plus or minus, but only through DHL or FedEx. The problem with them is they charge $25 for delivery, plus they add on a bunch of extra fees, or they will not give you your package, which is a giant scam. Plus they report the value to Thai customs, and then you get to pay tax on it. Now, I don't mind paying tax on $68, but the tax is on delivery plus fees, so I'm not paying tax on $120 for this. Anyway, so it looks like I'm going to take a breather for a while until this thing comes in, and I've also got my replacement ribbon cable on the way, and I bought a pack of 5 for $4.56. And hopefully I can get myself back on the air. But I'm going to close down this video now, admit defeat, and go to sleep. Oh, I'm also going up to Bangkok for a couple of days for a birthday party, and I'm going to bring the ICE device with me and go around the electronics neighborhood and see if anybody can sell me one and put it in my hand. Although it's really, really obscure. And I don't know if anybody's going to have it there, but it's worth a try. As you stare out on my beach, I would ask you to subscribe to my channel and click like on this video so YouTube thinks I'm worthy again, and I have so many people on my channel that they'll give me 10 cents a day in ad revenue. So I thank you for that.